Hello fellow game makers. In this tutorial I'm going to show you how you can create your own custom 2D geometry inside GameMaker Studio. GameMaker has methods to create simple shapes like circles, rectangles, triangles, but what if you want to create your own custom shapes? That's what we're going to have a look at here. And I call this the ribbon project because what we're going to do is we're going to take a path resource in GameMaker and apply custom geometry along it so that it gets a width and basically becomes a ribbon. And in the second step of this tutorial, you'll then learn how to apply a texture to this ribbon so that you could, for example, take a sprite and deform it along a path in GameMaker. Now, I know that there are assets out there that you can download or buy that do sprite deformation along paths in GameMaker, but I want to use this tutorial to show you the basics of creating geometry so that you can use those basics for your own future projects. There are a couple of steps that you have to go through when you want to create your own custom geometry. The first thing is to understand what is geometry actually in game engines. Well, it is nothing else but a bunch of triangles. This is an example for three-dimensional geometry, and as you can see, it's nothing else but triangles that make up the surface of the object. And 2D geometry is even easier because every corner point of the triangles doesn't need 3 coordinates like in 3D space, but only 2, an x and a y coordinate. So the first step whenever you want to create your own custom geometry is you have to think about how do you want to lay out your triangles. And of course you can start drawing a random bunch of triangles and try to get the shape, but it makes always sense to think about a structured approach because the more structured your triangles are laid out, the easier it becomes to later program them and create them in GameMaker. In this case, I've decided for this distribution. What we're basically going to do is we're going to divide the path into segments, which are these perpendicular lines here, and each segment is made up of 2 triangles. For the rest of this tutorial, we're only going to focus on this very first part of the geometry, because if you understand how the first segments are being created, you also understand how the rest of the path is being done. So let's zoom in here, and for now, we're only going to focus on this very first triangle we want to create. That means we need these coordinates of this corner point here, the corner points down here, and the third coordinates up here. And right now, we have none of them. Well, what do we actually have? What we have is the original path along which we want to create the geometry. Unfortunately, the path points that we use in GameMaker to create and define the path are of no use for us because as you can see, some of them don't even lie on the path. They're just anchor points to create the curves. But luckily GameMaker has methods to get the x and y coordinates along the path, and they're called pathGetX and pathGetY. And you feed them a position between 0 and 1. If you ask for the coordinates at point 0, you will get the very coordinates at the beginning of the path. If you ask for the coordinates at position 1, you'll get the coordinates at the end of the path. And if you feed it anything in between, like for example 0.5, you will get the coordinates at the halfway point along the path. So that means that our first point here at the beginning of the path actually has the coordinates pathGetX at position 0 and pathGetY at position 0. We now have to find out how we can use this point, these coordinates, to get to this point up here, which is the first corner point that we want to define of the first triangle we want to draw. Now this is a vector. A vector has 2 components, a length and a direction. The length in this case is simple. Whatever the width of the ribbon in the end is, we need half of that, and that's the length of our vector. But what about the direction of this vector? Where is it actually pointing? Well, looks like there is a 90-degree angle between this vector and the original path at this position. Now, unfortunately, 1 point is not enough to define a direction, so we need at least a second point. And for that, we'll just look a little bit ahead along the path, and we'll actually take this point here at the next segment. I just said I want to go 1% forward in the path, so 0.01. This is an arbitrary value. We'll talk about that more later. And now that I have these 2 points, I can use GameMaker's method pointDirection, feed the 2 points in, and I will get the direction from point P to point N. If I add 90 degrees to that, remember in GameMaker the angle increases counterclockwise, so if I add 90 degrees to this direction, I will actually get the direction of the vector that's pointing in this direction. So now I have the vector, I have its length, which is the width divided by 2, and I have its direction, which is the direction along the path plus 90 degrees, but I still don't have the coordinates of my target point. What are the coordinates of this point here in the corner of the first triangle? Well, to get there, you need to know that every two-dimensional vector has two components, an x component and a y component. And if I add the x component to my starting point, which in this case is a negative value, and also add the y component, I will actually get from the starting point to my end point. And luckily, GameMaker has methods to extract the x and y components from a vector. They're called length dir x and length dir y. If you feed them the vector, which is made up of a length and a direction, it will calculate the x component and the y component for you. If you add those to the starting point, we will get the coordinates of our first corner point of the triangle. And luckily, almost the same formula gives us the coordinates for the point down here, because it's just at the opposite side of the starting point. So all we need to do is subtract the components, subtract the x component and subtract the y component, and we'll get the point down here. And if you understand how these first 2 points were calculated, well, everything else is self-explanatory. We do all the same steps, but beginning from the next segment. So we start at this point here at 0.01, we look forward to this point at position 0.02, calculate the direction, add 90 degrees to get this vector, and then we have this point, and we have this point, and we do the same all the way to the very end of the path. The last thing you need to understand before we can actually start drawing the geometry is you have to understand how geometry is defined in GameMaker. There are lots of different ways to define custom geometry in GameMaker. You have methods to define a list of points, lines, but that's not what we want here. We want triangles. But which of these methods? Well, for the PR triangle list, you always need to feed 3 corner points, 3 coordinates, and it will then create a triangle between these 3 points. You feed the next 3 points, it will create another triangle. This is good if you have separate triangles which are not conjoined, but that's not what we have here. The PR triangle fan has one first corner point. The first point that you define is the center point, and all the other points create triangles with this central point. That's also not what we want. This is good if you want to, for example, draw circles. What we need is PR triangle strip. It already looks like what we want. It's like a ribbon. When you define the first 2 points, no geometry is yet created. But as soon as you create the third corner point, it will create a triangle with the previous 2 coordinates. So point 3 will form a triangle with 2 and 1. And from that point onward, this rule always applies. So if you add a new corner point, point 4, it will create a triangle with the 2 previous corner points, 3 and 2. So you always only need to add 1 more point, and it will create a triangle with the 2 previous corner points. Now let's have a look what that means for our ribbon project. You need 3 corner points to create the first triangle. These 2 points down here do not yet create any geometry, and still you need to define them first. And then as soon as you add this third point up here, the first triangle will be drawn. Then as soon as you add this point down here, the next triangle will be drawn. And you can see now that this will be an automatic process. You add this point and the next triangle is created, and so on all the way until the end of the path. And here is the code you need to actually draw the geometry. You have to start by calling draw primitive begin, which tells GameMaker that you're now going to define custom geometry. You have to tell it what type of custom geometry you want to define, in our case triangle strip. And now you have to add the vertices. The vertices are the corner points with the x and y coordinate of the corners of the triangles. And in this case, for the first segment, you would need 4 vertices. And in the end, you call draw primitive end, which ends the definition and actually draws the final geometry to the screen. Let's see what that looks like in GameMaker. All I've done here is create an empty room, and now we're going to add our path resource. I'll call that ribbon. We will make an open path with a smooth curve, add a couple of points, and create an object that will draw the ribbon for us and put that in the first room. Let's first just add a draw event and draw the path as it is right now. And we'll see the normal path without any thickness to it. Now in the create event, I will create the variable that defines the width of the path, and we'll use 64 for that. And now in the draw event, I'm going to add a new code block that draws our ribbon over the existing path. So what do we need to do first? We need to tell GameMaker that we now want to draw geometry. Draw primitive begin. Tell it what type of geometry, and in this case we said we want the triangle strip. And now we have to calculate the first coordinates. First we said we want the position along the path at %0, so the very beginning of the path. The same for the y coordinate. From this point we want to look ahead to the next point at 0.01, so 1% down the path. Again, this is an arbitrary number. We're going to talk about that more later on. That's our new point xy. And now we can create or calculate the direction from P to N. And let's not forget, we need to add 90 to that, 90 degrees to that, to get the final direction of the vector we need. The length of the vector we said is easy. It's just the width of the path divided by 2. And now we can actually extract the x and y components of this vector. The x component is length dir x. The vector length is L and the direction is D. And the same for the y component of this vector, length dir y. And now we can start drawing our vertices. The first one is at starting point plus the vector components. And the second point is the starting point minus the vector coordinates, so that we get to the opposite side of the path. Finally, we finish the drawing process by calling draw primitive end. And I know that something's missing, but I just want to show you that now that we have created 2 vertices, this is not enough to yet see any geometry, because 2 points don't make up a triangle. So we need at least 1 more point. I'm going to be very cheap here. In the end, we're going to change that, but I'll just copy this whole block here and insert it 1 more time, change the original position from 0 to 0.01, because now we start at 0.01. We look forward to 0.02 to calculate the direction. At 90, the rest stays the same. And I will only add 1 vertex now, so that we now have 3 vertices, and you can see that the first piece of our geometry is being created. If we add the 4th point, we can see that the first segment is already finished. Well, and from here, it's just an endless repetition all the way to position 1, the end of the path. Now you could copy this code block multiple times, but that would be very unflexible and very inefficient. So what we're going to do instead is we're going to create a loop that loops through this block for as long as we need until we reach the end of the path. So let's get rid of that duplicated code block, and let's actually add a for loop around the block that we already have. We'll use I to count through the loop, so from I equals 0 until I is smaller than 1, which is the end of the path, let's increase I by 0.01. Now we need to adapt this because we need the relative values now. So at the very beginning I is 0, so we look at 0. Then we look 0.01, so 1% forward along the path from the current position, and then we create the two vertices that are at position I. And then we increase I by 0.01, and that goes all the way up until we almost reach 1. I'll talk about why we don't want to reach 1 in a second, but let's have a look at what the result looks like right now. Well, that looks quite nice. The only thing that you notice is that the last segment here hasn't been created. The reason for that is that this for loop only runs while I is smaller than 1. It would need to run all the way up to 1 in order to also catch that last segment. Well, if you do that, you will actually see an interesting artifact, something that we don't want to happen. Look at that. What's happening here? That code has worked all the way from here to here. Why does it not work at the very end? Think about that for a second. The answer is that we always look 0.01 forward along the path to calculate the position at the current point of the path. If we are at 1, we can't look any further in the direction of the path because the path ends at 1. And that means that we can only count until we are one step below 1. Now, if you really want to catch that last part of the path, you would indeed have to copy this block and do a little trick here. For this last point, you do not look forward, but you look backward. So you look backward, and then because we look backward, we also need to subtract 90 here so that we get the correct direction for the vector. Let's see whether this has actually solved our problem. Yep, now the ribbon is being created all the way to the very end of the path. There is one more problem with closed path. So let's change the path resource to a closed path. You can see that the very last segment here is not actually being created. Before we address this problem, I think it is now also time to talk about this 0.01 business. It seems to be a good value right now to step through the path at 1% increments, but what if you want to change that later on? So I would suggest having this step size as a variable as well. So in the create event, let's not just define the width, but also the step size with which we go through the path, and let's have 0.01 for now. Let's adapt the code here to use this new variable. And we should actually not see any changes at all. But let's now change the step size to something a little bit more rough. Let's say 0.1. Now you can see that this step size of 0.1 means that we only take 10 steps to go from the beginning to the end of the path. And that results in a rather rough shape. But you can decide what value you want to go for to find the balance between performance and accuracy. We can actually increase the accuracy right now a little bit by changing a line in the code. I'm talking about this new point here that we use to then calculate the direction at point P. Right now, we jump all the way forward to the next segment in the path in order to calculate this direction. The more we move closer to the current point, the more accurate the direction at that point will be calculated. So we can modify this and divide the step size, for example, by 4 here. So we only jump a quarter of the step size forward to calculate the direction at the current point. And you will see that that will actually already have quite an impact on the accuracy of the shape of the ribbon. So let's check that out. And you can see, even though we have a very low number of steps, the ribbon now looks as if it better matches the original path. Back to our problem that we still have a gap here at the end of the path. Well, that is because our for loop only runs to the end of the path. There is no code right now that goes from the end of the path back to the beginning to close that last segment. So we actually need to draw 2 more triangles that connect the end of the path to the beginning. That means we need to save the beginning coordinates so that we can later reuse them to close the gap. So if I is 0 at the very beginning of the path, we'll actually save the coordinates of these first two vertices into separate variables. So that would be the starting point 1x the starting point 1y, the starting point 2x, and the starting point 2y. Now that we have those, we can reuse them at the end of the drawing process. Actually, this whole part where we calculate the direction of the very last segment, that is only needed when we have an open path. So we can add an if condition here. If path get closed equals false, then we have to calculate the direction of the last segment. Otherwise, we'll just draw two more vertices, and those are the starting coordinates that we have saved earlier. So that closes the gap back to the first 2 points. Let's see whether that has actually worked. I think that looks quite good. Now we would be finished with this first part of the tutorial, but I said I wanted to give you an overview of all the basics of creating custom geometry. There's one more tip I want to give you, and that is about speed and efficiency. Let's increase the step size back to 0.01, or rather decrease, so that we have more steps along the path. And let's also activate the debug overlay so that we can have a look at the frames per second. Now, the values here fluctuate, but it's around 600 to 800. Let's remember that number and we'll come back to it later on. Because right now the big bottleneck of the way you create the geometry is that in the draw event, every step you have to calculate all the corner points for the geometry, even though the geometry doesn't change. But if you know for a fact that the geometry will never change, it may move around the screen, but the geometry itself will not change, then there is a way to calculate the points and coordinates only once and then draw them every step. And that gives you a dramatic speed increase. For that we use methods in GameMaker that usually are reserved for 3D games. But what a lot of people don't know is that they also work in 2D games if you just leave out the third coordinate, the Z coordinate. And those are the direct 3D model functions. There is a set of functions that you can use to prepare a model, feed all the vertices in it, and then later you can access it and just draw it to the screen without recalculating all the points. I have prepared the script that we need, so we will get rid of this code in the draw event because we're not going to calculate all the points every step. Instead we go to the create event and we add a new code block here, and let's have a look at this code. We create a model for our geometry with this code, and it is essentially the same as before, just a couple of differences. First, we have to define the model that we want to create, give it a name, and call Direct3D Model Create. Now I always also call Direct3D Model Clear to make sure that the model really is void of any data. And now we tell it that we are going to feed geometry information into that model. Call Direct3D Model Primitive Begin. Add the model that we're going to use and the method we want to use to feed it the geometry. And now you use the same code as before. The only change is that you do not call draw vertex, but you need the Direct3D Model Vertex method, where you again give it the model that it refers to. Now you add the x coordinate, you add the y coordinate, and now you would have to add a z coordinate, but we don't have that in a 2D game, so you just set that to 0. All the rest of the code stays the same. Wherever you want to add vertices, you have to use the direct3d function. And at the very end, as the last line, you call direct3d model primitive end. With this code, you have now created a model that stores your geometric information, and you can access that with one single line of code in the draw event. So instead of drawing the ribbon all the time, we are now going to just draw the model of the ribbon. And for that, you use the method direct3d model draw, give it the name of the model you want to draw, and then the x, y, and z position where on the screen you want to draw it. Since the vertices are already at the correct positions relative to the screen, you can draw it at 0, 0, 0, and everything will be at the correct coordinates. You could also change these here to shift the model around the screen. And finally, you have to add a texture, but since we are not working with textures yet, you just pass -1 for no texture. Hopefully, we will see that it looks exactly the same as before, but let's have a look at the frames per second. Ha! Now, would you believe that? They are now at around 1,500, 1,700, so more than twice the frames per second than before. And that goes to show that if you have a geometry that does not change, you can use these direct3d methods in order to pre-calculate it and then only draw it to the screen very efficiently. That's it for part 1. Wow, that was quite a lot. In part 2, I'm going to show you how you can change this from a black ribbon into a textured ribbon and give you a couple of hints about textures in general. And in the third part, we're then going to have a look at what we can actually use this spectacular ribbon technology for in a couple of examples that you may use in your games. So, see you in part 2 and 3.